Hi guys, we got another quick video on HTZ Warfare and some of the automated workflows that can be unlocked using HTZ Web API. As many of you might already know, HTZ Warfare is HTZ's flagship electronic warfare simulation tool, able to model all types of tactical wireless communications. It's used by armed forces globally. So, and it's COTS software with its own native JS engine. It opens up a whole bunch of technical analysis. It's a very powerful engineering tool. Again, probably don't have time to go into all of these, but this is just scratching the surface, really, of what HTZ is able to do. So what we'll do is we'll start going straight to specific workflow that's made possible using the RESTful API. So what it allows us to do is to build, it takes that powerful analysis tool of HTZ Warfare and it turns it into a near real-time simulation tool of various battlefield scenarios. You're able to build quick customizable GUIs that are more suited for tactical operational requirements. But yeah, let's describe the workflow that we're going to go through today. So in this particular case, we've got, if you have a look at the first image, we've got a mesh network or a MANET network, ground-based troops moving around, right? Self-configuring links, right? So we're going to see how the links, what happens to the links as they're moving around this thick mountainous region, and which links are still valid, what new links are formed, and this time-based analysis is all made possible using the Web API, so you can visualize back and forth in time. That's kind of the basic idea. Right, Chris, let's take it away.
Okay, thank you, Edmund. So, right, so as you can see, this is the GUI that I designed using the API, and just note that you can design your own API GUI. Okay, so let's start the HTZ first. Right, and then we are going to load a project called ACT API. So the map area will be like ACT area, Australia. Okay, and then let's go to the stations and get the station list. Okay, as you can see, we've got some stations. We've got those mission units. Those are MU15 or MU3 or like it's MU7. Okay, those are all mission units. And then we are going to go straight to analysis, the MANET analysis. Then we are going to look at move MANET task. So let's display what links are available at the moment.
Based on the current network, right?
That's right.
Yeah. So.
Okay, so as you can see, the links has been established between those MANETs, mission units. And the links meaning is that those mission units can communicate each other with this link criteria. Later on, we will be look at it. And as you can see, the link colors are different. And those purple color, basically the link color represents the margin of link. So those purple color is like when the margin is above 20 dB, and the next from links is the blue and the green and yellow.
Based on link quality.
Yeah. Okay, so let's try to move some mission units. So I'm going to upload the CSV, move MU run 1. So this basically looks like this. We're going to move MU1 to this location, and MU2 to this location, and then so on. Okay, so let's move. Okay, so mission units have moved. Let's see the link status. So as you can see, some links are not valid anymore. You see the red links, okay, because of the movement, after the movement. So what we're going to do is we're going to identify those failed links based on this link criteria, which is minus 100 dBm and then within 10-kilometer distance. If I click identify, it tells me which links are failed. And what we're going to do is we're going to delete them. And then we are going to create a new possible link after the movement, okay? Because once the mission units have been moved to someplace new, there might be a new possible link that can be established. Okay, so this is the result of after this movement, okay? So you can see some new links generated and some failed links have been deleted. Now we will move another.
Before you move, Chris, so like again, what we showed was essentially checked a bunch of new coordinates, right? So the radio nodes or MANET radio nodes, they've been moving around, right? And obviously some of the links are no longer valid based on, you know, the obstructions, whatever gets in the way.
Yep.
And now we are able to see the new links, right, that are valid. Okay, that was really good. I just wanted to add one thing. This could be completely geolocation driven. So you
That's right.
Read XYZ coordinates of each radio nodes from a database, right? That's continuously populating. So you're able to have a real-time simulation for this.
That's right. Okay, so let's go to the move and you run through this one. And then this one looks like this. We're going to move mission units to this location. Okay, and let's move. Okay, so mission units have been moved. Let's see the current link status. Okay, as you can see, there are some failed links. So what we're going to do, we're going to identify those failed links. And we've got a bunch of failed links as well, as you can see in the table. So we're going to delete them. And then we're going
And again, we just wanted to show you which links failed, right?
Yeah.
But this can be automated as well.
That's
for
right.
deletion.
Okay, so after this movement, we create the new links and delete the failed links. But as you can see, these mission units have not linked with either of those mission units. Okay, so this mission unit is MU3. Maybe the nearest one is MU5 and MU1. So I want to show you why they are not linked together, okay? So why MU3 is not linked to MU5 and MU1. So we can quickly run this P2P calculation. So link from MU3, and then let's look at the MU5 first, okay? So we are looking at these two, why they are not linked. MU5, these two, okay? So let's run P2P, and there you go. So the power received at MU5 from MU3 is minus 103 dBm, which is lower than our link criteria, which is minus 100 dBm. That's why they're not linked. Then maybe let's analyze this MU3 and MU1. So from MU3 to MU1, run P2P. And then now this power received at MU1 is even lower, minus 106. That's why they are not linked together. Okay. So that's the reason why they're not linked together. So now we're going to move one last time. So we will upload this move MU run 3. And then those mission units will be moved. CC will be moved as well. Then let's click move.
So guys, this is really valuable for planning tactical ground-based missions. So you're able to simulate the movement of the troops, or it could be the other way around, where you're able to chuck their live coordinates in and see what the current state of the network is.
Okay, so after this last movement, you can see there are failed links. Okay, then we need to identify, and those are a bunch of failed links that failed. We're gonna delete them. And then we're gonna create a possible link. Okay, so this is basically how links is established with this after the last movement. Okay, and after that, as you can see, those troops cannot communicate each other. So what we want to do is we want to click search range extender. Okay, so we will look at the range. We will look at the location of optimal location of range extender to connect those 3 troops. So let's
Clusters. Yeah.
Yep. Search RE. All right.
So this is utilizing a function called
Search. Yeah.
search.
And while it's running, maybe we can sort of summarize, recap this movement. So it started from this here. Those are the links established at the beginning. And after the first movement, you see there are failed links. So, and then it becomes like this. We delete the failed links and create a new possible links. And after the second movement, it goes like this. And of course, there's a failed links. So we delete them and then create a new possible link. It goes like this. And I show you why this mission unit, NU3, is not.
So this is really the time-based analysis, right? You're able to visualize the moving network and see which links are valid and which are no longer valid at different points in time, right? And you're able to do that all, in one interface, which is that's what we mean by what we say, like it brings the analysis power capabilities of HTZ and makes super configurable automated workflows.
Yep.
Found the RE as well.
Yeah, found the range extender called node 1, and those are the this is the location. Okay. So range extender to be deployed, just one. And then let's just display the current link status. As you can see, this is the current link status. Now we want to look at how RE can bring those troops together. Okay, so we are going to link RE as well with the same link criteria. Let's create. And there you go. So now there is a link established between this RE and those troops.
So it found a location that's able to connect all the clusters.
That's right. Yeah.
Wow.
Yeah.
Just one more thing, Chris. Can you like at one of the earlier points in time, right? There was a cluster at the top where the nodes were really close, but it was not connected. Can you tell us why?
That's also get to do it using the P2P calculation, but we already picked the stations, so that P2P calculation will not be validated.
Will not be valid. Okay, because it's moved. Okay.
Yep.
All right. Okay. No worries. No, so we can.
Thank you, guys.